right, so transforming converts the original observations from original units of measurement to another scale. So we're going to talk about what happens when we add the same number to our data or subtract the same number from our data. How does that change the shape, the center, the spread, all that stuff. And same with if we multiply by a number, how that's going to change it. So this is just a general what the transformations could affect, the shape, the center, the spread, and we'll talk about exactly what happens. So first of all, I want you guys to estimate how wide, and that's going from here to here, this way, how wide you guys think this classroom is, and we're going to do it in meters. So you guys estimate in your brain, maybe write your number down, okay, how far you think it is from that wall to that wall in meters. Everyone's going to have to say a guess. It's okay if you're off, you know, this is just an estimate. So I have this software called Fathom, which makes graphs really quickly, and I don't really know how to use it. I'm going to be practicing, so this is a learning curve for me. So I apologize if it's slow. So first of all, you guys guess how far. So Zach, can you tell me how many meters you think it is? 15. Kyle? Oh my God. 20. Okay. Delaney? 20. 15. Don't let other people's guesses sway you, you guys. Charlie? Don't all pick 15 or this isn't going to be very good data. Dim. Thank you. Switch it up. Yeah. 13. 12. 18. Donovan. Okay, Ginger. Okay, Jake. I'm not putting that in. Yeah, Malcolm.
3.
Thank you. Switching it up. Okay. Yeah. 28. Aggressive. All right, David. 16. Whoops. 16. Yeah. 14. David. 30. Okay. Yep. 13. And 17. All right, so we're going to make a dot plot. If I can, if I know how to do this, we'll find out. All right. Woohoo! All right, so there's my dot plot. So if we did the socks thing, you guys, so shape, what would you guys say the shape of this is? Roughly symmetric. Okay. And then outliers? 3, potentially. Okay. Maybe 30 in the other high one, not maybe. Okay. What else we need? Like center, what would you guys say the median looks like? Okay, 15, 16, somewhere in there. And what's the last one? Spread. What's the spread? From 3 to 30? Or we could also find the IQR. All right. Cool. So there's our general information. Now what we're going to do is actually I'm going to tell you guys what it is. And we're going to find how far off you were. So we're going to call this the error, and you guys are going to have to help me with some subtraction. All right. So the actual number of meters is 12. You overestimated a little bit. Way to go. You got 12. All right, so if we got 12, the first person was off by how much? 3. If we got 12, the next person's off by how much? 8, 8, 3, 3. Okay, this person was off by how much? We got to do -2, okay? How much? 1, 0, 6, 7. Thanks. I need your help, you guys. 12, 7, okay. 2. Oh, yeah, 18. 1, 5. All right. So we had a lot of high guesses. So what we did just now to our data, what did we do to our data from all of our original values, you guys? Yeah, we subtracted how much? 12. All right, we subtracted 12, right? So So we want to find out what happens to our data when we subtract 12. I'm pretty sure there's a way to put these on the same graph, but I don't know how. So we're going to just do a separate graph and compare them. So I'm going to line up the zeros of the x-axis, right? So what happened from this data to this data, you guys? It shifted left 12. That makes sense, right? Is the shape the same? Yes. What happened to the center? Went down by 12. Okay, what happened to the spread? Went down by 12. It's the same spread, but it went down by 12, right, for that? All right, so let's talk about what we should write down. Okay, so this is what you want in your notes. What happens when we add or subtract by a constant? So if you add or subtract, it will add that amount or subtract that amount from your measures of center and location. Okay, so the mean will drop by 12. The median will drop by 12. The quartiles will drop by 12. Okay, it does not change the shape. It also doesn't change the range, right? Our high minus our low would be that same number. Now it changed our actual max and our actual min, but it doesn't change the range or the IQR or the standard deviation. Okay, so adding and subtracting changes everything but the distribution and spread. Okay, what if we decide to convert our air data to feet? All right, so we'll go back over here. We're going to convert our air data to feet. Anyone know how many feet are in a meter? So it's 3.28. Someone get a calculator so you can help me plug these in, because I'm definitely not doing that in my head. 3.28. So our air data, maybe a few of you guys can help me out, more than just Donovan. Thank you, Donovan. All right, 3 times 3.28, what is it? I'm sure there's a shortcut way to do this on software, but I don't know how, so I have to do it myself. 9.84? Okay, what's the next one? Thank you. What's the next one? Oh, same. And same. And same. Okay, how about this one? Okay. And 6. Thank you. And 5. For what? Thanks. 7. Okay. -9. Okay, 16. Okay, 4. Okay. Thanks. 2 was 6.56. 18. And 5. 16.4. All right, so let's see what happens to our data when we do another graph. Again, I'm comparing it to the air data. All we did was multiply our air data. Okay, so notice the numbers and the shape, right? So what do you notice about the shape? Same. All right, how about your like median or your mean? Is the same? Check out your x-axis, right? What would this one be? It is multiplied by what, you guys? Okay, good. The median and the mean are multiplied by 3.28. So how about your spread? Did your spread change this time? Yeah, if you take the high minus the low, is it going to be a different number? Yes. So our spread did not change when we just added or subtracted, right? Our high minus our low stayed the same when we just subtracted 12. But over here, our high number is like way bigger, and our low number is way lower. So our spread definitely changed. So what's the only thing that did not change when we multiplied? Yes, shape. Okay? So let's write some notes down so we have that. This is multiplying or dividing. Has the same concept. You're going to multiply your measures of center by that same number. Okay? And we'll multiply our measures of spread as well this time by that same number. And the only thing that doesn't change when you multiply or divide is the shape of the distribution. All right, so write that down in as short of notes as possible. Okay, so z-scores. This is going to be a big deal for this chapter and for a while. So we talked about z-scores yesterday when we talked about, well, really, how well did Malcolm do when he got an 86% on the test, right? Like, comparatively to the rest of the class. So we standardized everything with z-scores. So just a reminder that to find the z-score, we take your data point and we subtract the mean and we divide by the standard deviation, right? So here's the test scores where we have it in normal percentages right here. We have a little dot plot. Okay, this is everyone's test scores, not really, but pretend test scores. And then down here, we standardized every single one, right? Standardized. So when you standardize, you're subtracting something and you're dividing by something, correct? Okay, so we're talking about transformations here. What happens to the shape of those distributions? They are the same. Okay, good news. So when we transform to z-scores, we have the same shape of distribution. Now the center, this always happens when we change it to z-scores. What do you guys notice the center is at when we look at the z-scores dot plot? 0. So your center will always be 0 when you standardize your data. Okay. And for your spread, like our spread before was 6.07. I don't know if you guys remember that. We found the standard deviation. It was like 6.07 yesterday. When you standardize it, your spread is always going to be 1. Okay. Each standardized spread, standard deviation is 1. Okay, so our center is our new mean, and our spread is our standard deviation, always becomes 1. Okay, so whenever you standardize, it's just going to put it on a nice scale. Let's see if we understood what happened. So suppose that you convert the class's heights from inches to centimeters, right? So 1 inch is equal to 2.54 centimeters. That means we are doing what, you guys? What operation? We are multiplying. Okay, if we're converting our height from inches to centimeters, describe the effect it will have on the shape, center, and spread. So someone raise your hand and tell me, if we multiply by 2.54 to all our data, what happens to the shape? Thank you, Taylor. It stays the same. Okay, and what happens to the center if we multiply all the data by 2.54? It is also multiplied by 2.54. Cool. And how about the spread if we multiply by 2.54? It is also multiplied by 2.54. Okay? Shape will not change. However, it will multiply the mean and the median and the spread, whichever spread you use, range, IQR, standard deviation even, by 2.54. Okay? So even standard deviation gets multiplied by 2.54. All right. Let's look at another one. If Mrs. Navard had the entire class stand on a 6-inch high platform and then had the students measure the distance from the top of their heads to the ground, so what are we doing, you guys? We are adding 6 inches to everyone's height. All right, so raise your hand if you know what happens to the shape when we add 6 inches. Taylor? Very good. Nothing. It stays the same. Okay, we should probably say same. And how about the center, Owen? What happens to the center? Yeah, the center will also add 6, whether that's the mean or the median, all right? And the spread, when we add something, you guys, does the spread change? No. All right, your IQR stays the same. So just because you subtracted 12 or added 6, whatever you did, it still has the same spread. Okay, so there's our answer. And last one, now suppose you convert the class's heights to z-scores. What would be the shape, center, and spread of the distribution? So the shape, you guys, what happens to the shape when we convert to z-scores? Stays the same. Good, we got this. What is the center always? 0. What is the spread always, or the standard deviation? 1. Okay, the mean will be 0, and the standard deviation will be 1. That is it.